But what's really exciting about the Althea blockchain is not only the ability to onboard fund. Well, first of all, it's the ability to onboard funds more cheaply by using onboarding into the Cosmos ecosystem as opposed to onboarding into the ETH ecosystem to avoid the Ethereum fees. But also, it's the ability to integrate more and more DeFi sort of functionality into the routers directly. So this is stuff that people are doing informally right now. For example, a revenue share on the routers is so how we envision that working is that the Althea blockchain has the so it's going to be integrating Ethernet. So that means it has the Cosmos blockchain layer and sort of the Ethernet EVM, the Ethernet EVM within that. And the routers transact on the Cosmos blockchain layer, which means that we have a native module that's very efficient and can prioritize transactions from routers above EVM operations. But then within the EVM, we're going to have integrations with the routers. So it can be possible for a router to say like, hey, I'm going to have a revenue share contract, and that can be enforced, or not necessarily enforced, but that can be actually operated inside the EVM. For example, you hold, for example, you can hold an NFT which represents 20% of the revenue of this router. So in that way, you can start to really compound the effects and manage some of this more automatically. And this is what we get into. This is where we get into what we call liquid infrastructure, which we mostly envision as a way to automate and make Althea routers composable. So the revenue made by Althea routers, the infrastructure, the physical infrastructure can have a composable revenue share that can then be used in DeFi, which brings about interesting things like loans against future revenue, and the ability to, for example, trade these NFTs, which each represent a share of a particular router's profits. So yeah, because this is all integrated directly into the blockchain where the transactions are happening in the first place, this can actually be enforced very smoothly, and create a sort of decentralized representation of the physical goods. And this is the really interesting and promising sort of stuff as far as additional developments and new ideas. And then there's some more boring, simple stuff, like, for example, Cosmos has instant finality. Instant finality is great. You don't have to wait for transactions to be processed. So that alone is a really big improvement as far as simplifying the code in the routers and making things generally work better and more smoothly than they can on XDAI or Ethereum.
Justin, I was curious your thoughts on transaction prioritization or transaction, basically different sort of transaction ordering in the Cosmos or Althea chain.
Yeah, so particularly what we're going to do, because the Althea chain is a platform that is both for DeFi and also for infrastructure-based DeFi, and also as the actual settlement layer for the routers, is that validators will be set up to pull transactions to pull router transactions from the mempool with priority. And what this means is that in the case we see something like what happened yesterday on Ethereum with the Blur airdrop claim, is that can be going on the EVM, and it will fill in the edges around the router transactions. So the router transactions will never have to wait. And this direct integration that the routers have with the blockchain will also allow them to do interesting stuff. Like, for example, how frequently the router should make payments can be a consensus parameter, which means that for example, if there's a lot of capacity on the blockchain, you can pay every 5 cents or every 10 cents, which is better for everybody because everything is settled more fine-grained. There's less bandwidth per transaction and less to potentially get confused about. But as the chain becomes more and more loaded, the consensus parameter for the minimum size of one of these transactions can be increased to like 30 cents, 50 cents in order to sort of manage the load. So this sort of closed feedback loop allows the Althea blockchain combined with the Althea routers to deal with spikes in traffic very sort of in a very dynamic and sort of optimized way. And you'll notice that this is essentially a solution for the microtransaction scaling problem, which is very specific to the use case of distributed infrastructure. So with Cosmos, we get instant finality, so that's great. We also get fairly high throughput, higher potential throughput than Ethereum, if we really want to push it. But combined with this sort of dynamic scaling mechanism, the need for L2s or additional complexity on top of the Althea blockchain is dramatically reduced, and lets us say like, hey, look, the Althea blockchain is it for this use case because we can continue to scale onto relatively arbitrary size and number of transactions just by virtue of using this highly specific microtransaction type, which we are free to optimize and tweak and help round out load spikes and other potential issues. And then, what's really great is that we have instant finality, which is so incredibly simplifying you would not even believe it. When you have to deal with waiting 15 minutes for finality on an ETH chain for a microtransaction, you're trying to send 10 cents and now you got to wait 14 minutes to know if it's good or not. I mean, it's you would not believe how complicated that queue system is. It's thousands of lines of code that are just like, well, is the transaction in yet? Okay, has somebody paid us? Okay, do they have a payment in flight to us that we should maybe consider credited? Okay, did this payment fail? Okay, now we have to resend it. Oh no, we already have a payment in flight. We have to count that against the next payment we want to send. You would not believe it. And reducing that complexity is going to help increase the reliability of the routers by a pretty large margin, in addition to just increasing the underlying blockchain reliability for this purpose, the other scaling techniques that I talked about. So as you can see, there's really a lot of different improvements for a very tight and very stable system, which is what we need if we want to take the Althea blockchain from something that right now is stable enough for right now, Althea as a product is stable enough for home internet, and it's more stable than the home internet a lot of people have. But we need it to be stable enough to be the settlement layer for the internet, which is a completely different challenge. It's a lot more nines on that uptime. These are the sorts of changes and the sort of thinking that's going to let us get from here to there. So let's say we have A, B, C here. So obviously A pays B and B pays C, but they both pay each other in lump sums based on how many cents worth of bandwidth is used. So what this means is that if you're going to move a gig through the system from end to end, and a gig worth of bandwidth is going to generate X payments from A to B, and then Y payments from B to C. But what you have to understand is that it's not exponential, but there's a linear, because each router adds its payment amount in the, So in the modification to the Babel routing protocol where we advertise Althea prices, each router adds their price at each hop to the sum total, which means that as you get deeper into the network, the prices reduce, and thus the total number of payments also goes down since they aggregate. And also, as you get more relays behind more clients behind a single relay, those payments all aggregate into the upstream. Since the upstream will be paying. Okay, let's say we have. So we have ABC, and then C has like 10 routers off of it, so it has 10 clients. So if those 10 clients use a lot of data, they pay C pretty like irregularly, maybe once every couple of hours. Then B and C settle more often than that because they're moving more data, so maybe once every 10 minutes. And then A and B settle maybe once every 5 minutes. But remember that at each level, more data is bundled into this. So there is the ability to sort of continue to aggregate payments and increase efficiency. Now, I'm trying to come up with a good expression for the reduction in complexity, but essentially the complexity doesn't necessarily, so if you add 100 routers, you're not going to be sending 100 times as many transactions. You may be sending 100 times as many value, you may be sending 100 times as much value, but you're only probably going to be sending around 70 or 60 times more transactions. And then so that's already roughly a 50% reduction. Then you combine this with the ability to dial up the minimum transaction size as chain load increases, and you can probably cut the knees off of the spikes, because this is a spiky graph, right? So that means that, let's say at prime time, we go from 10 cents per transaction to 50 cents per transaction. That is an exponential reduction in the number of transactions required. So you can get down to another 10x or so pretty easily there, which means that if you add 100 times more routers, you could theoretically only have 5 times more load. So that gets you to the really sort of logarithmic growth that you need if you want to keep things simple. Not need a bunch of L2s is essentially what I'm talking about. Now, given the way Tendermint currently works, the problem is not going to be you have to upgrade your validator's hardware. The problem is going to be that you run out of storage. Because even though I've described a nice way to aggregate the number of transactions and keep us within a, let's say, 500 transactions per block limit fairly easily, and not have to try and mess with that, we are going to have a lot of full blocks to store. Now, this is where Tendermint as a consensus mechanism is really, really, really great, because once again, instant finality, and also it is really light client focused. That instant finality means that you can state sync a node. And I'm sure those of you who run Gravity Bridge validators are familiar with the concept of state syncing. And that is where you catch up with the current state of the blockchain by receiving a very compact representation. And you don't necessarily grab all of the like historical data. So on Ethereum, when you sync a full node, you are state synced to the current head as far as consensus in a matter of less than 5 minutes. What takes days is getting all the transaction history. But if you're a router and you are just sending payments from one router to another, you don't need transaction history. You only need the current state of the blockchain, which you can sync in just a few megabytes. And even less than that, if we continue to work on proper optimization as far as being able to store only part of the chain state Merkle tree. So what this essentially means is that with the Althea blockchain and probably a few years of additional development, we will be able to eliminate the need for routers to talk to full nodes. Instead, routers will run their own efficient light client and keep up with the current state of the blockchain. And they will even be able to participate. Well, you'll need more power than a normal router for this. You'll need to be able to store the entire chain state. And the entire chain state may be several gigabytes of memory, but the storage we can mostly outsource to state syncing, where very, very few nodes run full archives. And instead, We get to the current head state of the blockchain purely via state sync. And this brings up a really interesting question, where what happens when the history of Althea chain, after being the settlement layer for the internet for 20 years, the history is like a billion yottabytes or something crazy. We actually don't need any of it. We can toss it all, and nobody has to store it ever. Because as long as we can maintain the current state of the blockchain on a single node, and people can state sync to that, we can continue forward with consensus. And this is the property of Tendermint that I really, really like for the Althea blockchain, because it helps solve these long-term problems, and it really fits the Althea philosophy of, and this is something we like to do with everything that we do, is to have solutions that are so radically simple that once explained, now that I've explained this, you're like, oh man, where is the blockchain scaling problem? I don't see it, because we have just sort of danced around the whole thing.